Hi, we have the AP Physics 1 past paper 2023. We are discussing free response question section. In this part, we have the question number 1 which carry the 7 points. A question is a cart on a horizontal surface is attached to the spring. The other end of the spring is attached to the wall as shown in the figure. The cart is initially at the head at rest, as shown in a fig. When the cart is released, the spring consisting of the cart and the spring oscillate between plus L and minus L. So this is the value where in between the spring and the cart oscillate. Fig 2 show the kinetic energy of the cart spring system as a function of system potential energy. Frictional forces are negligible. So it is from the graph, it is ideally kinetic energy. At extreme, it is totally potential it is kinetic energy, and the 4 joule is potential energy. Mean energy remain the same. Either it is potential energy or it is kinetic energy. When it is extreme extended, it is carry the potential energy. When passing through the mean position, it carry the extreme kinetic energy. So the question is, on a graph, kinetic energy versus potential energy shown in a fig 2, the value of x-intercept and y-intercept are same. Explain why this is true using the principle. So we come to know the total mechanical energy of the system remains constant since we have considered there is no friction. Law of conservation of energy state, total energy kinetic plus potential remains constant. At y-intercept represent the moment when u is equal to 0. At this moment, all of energy is kinetic energy. This happens when the cart system is passing through the equilibrium position x is equal to 0. So, x-intercept represents the moment when the k is equal to 0. At this point, all of energy is equal to potential energy. So, at that moment, kinetic energy is 0. So, there is an extreme position when cart spring system is fully extended. Because the total energy doesn't change, the maximum amount of kinetic you can must have equal to the maximum amount of potential. That's why both intercept are exactly same value 4 joule in this case you are seeing from the graph. Okay, the next part of the question. When a cart is at plus L, mean at its extreme position, momentarily rest because there is a kinetic zero, wholly energy is potential energy. A block is dropped into the cart as we have seen fig 3. The blocks stick to the card. The block card system string continue to oscillate between negative L and positive L. The masses of the cart and the block are m0 and 3m0 respectively. We are seeing from the fig. Now the question is frequency of oscillation before the block is dropped on the cart is f1. The frequency of oscillation after the block drop is f2. Calculate the numerical value. We have the value of frequency f is equal to 1 over 2 pi square root k by m. K is the spring constant, m is the mass of the system, for f2 divided by f1. F2 is the after, so total mass is equal to m naught plus 3 m naught. So that's become the 4 m naught. So k is the same to 1 over 2 pi is the constant. So in case of f1, only change is equal to m naught before the block is dropped. So 1 over 2 pi, 1 over 2 pi cancel, k is cancelled. So we have square root m naught over 4 m naught because it move up and it move down as that. Okay. Now m naught is cancelled, square root 1 by 2 is equal to square root 1 over 4 is equal to 1 by 2. So the ratio is 1 by 2. Now the next part of the question. The dashed line in a fig 4 show the kinetic energy versus potential energy of the block or system after the block is dropped. Mean when the block is dropped onto the cart, the graph is identical to the graph shown in a fig 2 for the cart spring system before the block was dropped onto the cart. Explain why the two graphs must be the same using the Fick's principle. So as you can see fig number 4 and now see fig number 4, there is identical. 4 joule kinetic, 4 joule potential, same is representing here. 4 joule kinetic, 4 joule potential. Now, what's the reason? When the block is dropped at the cart, x is equal to plus L, the cart is momentarily at rest, mean there is no kinetic energy. at that moment. So cart is not moving. Adding the block doesn't change the kinetic energy. So at that instant, kinetic energy is zero. If you change the mass, there is no change in kinetic energy. Now the potential energy of the spring depend upon the stretch 1 by 2 kx square. So spring is stretched by the same amount, x is equal to plus L. When the block is added, spring potential energy is unchanged. Mean there is no role of mass in this formula. So there is no dependence of potential energy on the mass. So total energy of the system is still 4J. So graph between K and U remain exactly the same in fig number 2, previous case. So that's the reason. Now, what's the question? Question is, after the block is dropped onto the cart, consider a system that consists only cart and the spring. On a fig 4, sketch the solid line that show the kinetic energy of the system consisting of the cart and the spring, not the block after the block drop of the cart. Okay. The maximum potential energy of the system doesn't depend upon the mass of the system. Therefore, there is no change in U, either there is block or no. So horizontal intercept is same as the intercept in previous graph, fig number 4, that represent the 4 joules. So both cases there is a no change in potential energy. But when the block stick, the cart and the block move together, so their whole kinetic energy is equal to 1 by 2. Total mass become 4m. So 4m not v square. But we have to discuss only cart and the spring system. So the cart share in this whole kinetic energy is 1 by 2 m naught v square. So that's the 1 by 4th mass of the total. So that 4m, that is m naught. So we can say cart is 1/4 of the total mass. So it carry the 1/4 of the total kinetic energy. So in that case, if kinetic energy is 4 joule when a whole block, cart and the spring, that case 4 joule when the whole system we consider at U is equal to 0, cart carry 1/4 of the it, that's only 1 by 4, 1 for 4, that's 1 joule equal to. So that's the complete line. I represent the 1 joule on the cart kinetic energy at that moment. Okay, that's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share it with your friends. Okay, take care.